Hi, my name is Amira Hnain from the Digital Research Center of Sfax. Today I will present ECLARISS, a security by design smart home surveillance system with edge dynamic biohashing, conducted jointly with Dr. Hadda Belhaj and Professor Lamia Shari. Today, we count over 15 billion IoT devices worldwide, including more than 1 billion surveillance cameras, most incorporating AI models that are updated every 3 to 6 months. This rapid evolution brings a serious hidden problem. Security mechanisms in smart home systems are tightly coupled to specific deep learning feature structures. Every time a model is updated, the entire security layer can break. And that leads to the three challenges we set out to solve. The first challenge, model dependency. Biometric templates are hard-coded to specific CNN architectures. When the model changes, protection breaks and users must re-enroll. The second challenge is edge IoT constraints. Cameras have limited compute and memory. Raw biometrics cannot go to the cloud, and heavyweight cryptography is too slow. The third challenge, and most overlooked, is the absence of formal guarantees. Most systems make security claims that are never formally proven, no proof against replay attacks, no verified unlinkability. We need a model agnostic protection, an edge deployable cryptography, and formal security proofs. Simultaneously, no existing system provides all three. Existing work falls into three streams. Cancelable biometrics address template protection but remain bound to specific feature structures. Zero trust frameworks focus on continuous verification but lack adaptive credential management after attacks. And formal verification tools have been applied to IoT protocols but consistently omit biometric specific properties such as unlinkability and irreversibility. None of these works jointly address all four gaps. ECLARISS is designed precisely to fill them all four together. So ECLARISS is a model agnostic security by design framework built on four pillars: dynamic biohashing and cancelable version controlled templates, NIST compliant SSA-based cryptography, zero trust architecture, and formal verification via ProVerif. These yields to three key principles: decoupling, which means sensing features and security are independent layers. Revocability and the privacy is first. Raw biometric data will never leave the devices. So we present here our methodology that contains mainly three steps. The first step is the principle definition, where we have defined 7 security by design principles derived from universal security standards. The second step is the life cycle integration. As you see in the figure, protection and functionality were refined in parallel. The third stage, threat-driven validation via street analysis, covering external attackers, malicious insiders, and physical intruders. These 7 principles are the operational backbone of ECLARISS, and through P6 are formally verified through ProVerif, which I will come to shortly. We validated against 3 adversarial profiles: external attackers, malicious insiders, and physical intruders. Each threat maps to a specific principle and mechanism. For example, we present here our architecture composed by 4 layers, all enforcing zero trust across layer. The first layer, the perception layer, that incorporates cameras and security mechanisms like TPMT, trust, and iOS cryptography. Layer 2, the edge processing, which is made mainly for the biohashing. The third layer, the security hub. Finally, the application layer that incorporates access decisions, tamper-proof logs, and GDPR consent dashboard. This is our core technical contribution. The camera extracts n-dimensional feature vector using any deep learning model. And then the security layer does not care which is the model. Then a user-specific key is generated from a versioned seed feature vector and key combined through a one-way transformation to produce the protected biohash. Six operational phases. Phase 0, hardware routed trust via ICDH inside the T. The shared secret never leaves secure hardware. Phase 1 enrolls, phase 2 authenticates. The critical detail, each use a different type target IID. And then phase 3 verifies by Hamming distance, and phase 4 and 5 they trigger autonomous renewal when the failure counter exceeds the threshold. We modeled all phases in ProVerif against a full Delevio adversary. 7 properties were formally verified as mutual authentication, biohash secrecy, session key secrecy, replay resistance, cross-protocol replay prevention, forward secrecy, and unlinkability. All queries are true. To our knowledge, this is the first formally verified set of biometric-specific security guarantees for a smart home IoT system. The system is implemented through a Raspberry Pi 4 microcard and has been tested. Here you can see some statistics from the experiments that has been performed. To 5 contributions, a formally grounded security by design methodology, model agnostic biometric protection, autonomous security hubs, ProVerif verified guarantees, and self-healing renewal mechanism, jointly filling 4 gaps, the 4 mentioned previously gaps. We are transparent about scope boundaries. Cross-family model transitions require dimension compatibility, and presentation and side channel attacks are outside the protocol scope. Thank you. I'm happy to take your questions.